Yes guys, welcome back to Pure Math School, and today we're going to look at basic algebraic manipulation, and these are what we're going to look at today. We're going to check on factorizing by grouping, expansion of algebraic expressions. Then under that we're going to look at single term products, that's of this form, when you have terms multiplying one term multiplying another term. Binomial products, we have a combination of two terms. Then we look at the three quadratic identities, but today we are going to first cover this first three here, and because it's the one that's going to help us in our next video as we go further. So today we are first going to introduce the basic things we need to know about this subtopic of the introductory work. And to start with, let us begin with single term multipliers. Single term multipliers could we have always one term maybe multiplying another. We say A multiplying bracket of which has addition of B and C, of which here we know that something that's going to be like this, and we're going to see how that comes about in the figure below. Let's assume we have a rectangle side A and another side B, and we want to bring about C. We add another small rectangle besides it, let me say of side C, and side A here, since this side A is the same as this one and the same as this one, and that would mean this is a distance from here up to here. That means our distance from here up to here will give it B plus C. Now let us maybe say name these vertices A, B, C and D. Then maybe here we put P, Q. Okay. Now what we are going to check on, we see that area of the rectangle A, B, C, D is going to be given by the area of rectangle A, Q, this point, P, that point, then D, plus the area of rectangle Q, this point, B, C and P. That will give us the area of the whole of this rectangle, and we know that area of a rectangle is given by length times the width. We have length of this rectangle B and the width is A, so area of this would say is going to be, the rectangle ABCD, the length is going to be from here up to here, that is B plus C, and the width will be simply A. So we are going to have length times width will be that A times that B plus C. So we are multiplying A with that bracket which has B plus C inside. You must area of the rectangle AQPD, this section here, is given by its length is B and its width is A. So that's going to be A times B would be AB, which is also length times width, plus area of the rectangle QBCP, which is this section here, this smaller rectangle, which its length is c and its width is a. That will be AC. So therefore we have our A into B plus C given by AB plus AC. If you realize that the single term multiplying this bracket multiplies each term inside the bracket, which is given here, and that's the expression one of the expressions we need to know before we start expanding our algebraic expressions. And we have to also notice this before we continue. We have to notice the sign that if you multiply positive multiplied by positive number, the result is to a positive sign, and if you multiply a negative number by a negative number, result will be negative sign. And if we can see that if you multiply, let me say negative 3 by 3, we're going to have here in by negative 3 by negative 3, we're going to have 9, which is coming from this. If we multiply positive 2 by positive 1, we're going to have 2 times 1, and positive times positive will give us positive 2. That's what we also need to know about that. That means if we multiply or divide any two numbers of the same sign, the result must be positive. That's our conclusion. Multiplying any two numbers by positive sign must give you multiplying two numbers of the same sign must give you a positive sign in the end. And another thing we have to see also when it comes to this condition, that we have a negative number multiplying a positive number, result must be a negative number. And if you're multiplying a positive number, let me say when the positive is out and the negative is inside, you must still end with a negative number. For example, we could say 2 into negative 1 will give us negative 2, and negative 1 times 2 would still give us negative 2. Here we conclude that in case you're multiplying any two numbers, and also applies for division, which have different signs, the result must always be a negative sign. And we can apply what we have discovered up here into maybe one example. A into A minus B squared. We're going to apply what we have discovered here, that the number outside the term outside the bracket multiplies each term inside the bracket. And now that means A times A here would be A squared, and A times B squared would be, but we are seeing that A is positive and B squared is a negative term, as a negative term in front of it, and we say multiplying positive by a negative, the numbers of different signs must result to a negative, so we remove the negative AB squared. The next thing we're going to look at is binomial products. The thing I need to look at is binomial products. Or multipliers. For this case, we have an algebraic expression of two terms, and for example, we can say x plus 2, and let me say 2a minus 3, 2p plus q. This algebraic expression has two terms, x plus x and 2. This one has 2a and 3. This one has 2p and q. That's what I mean by binomial products, by binomial terms. I mean binomial expressions. as two terms inside the bracket, or adding two terms. And we are going to see what we are going to look at, that we might have a binomial product expression of a plus b, and applying another binomial expression of, let me say, c plus d. This would say we after proving, we will realize that this will multiply each term. The result will be AC plus AD plus BC plus BD, and that's basically how we're going to see how we can come to that from this figure below. Let's have, we first create, we need A plus B, and we also need B plus C, I mean C plus D. So for that case, we can first of all put a rectangle here. We can name it A and B. We add, let me say, we add another term. Okay, I can call this lower one, let me say A, because I wanted to add B here, B, so that the whole of this will be A plus B, this length here. But here up to here is A, and here up to here is B. Let us say we give this side C. That means now here will also be C. Same length. That. Then now, how do we bring D? That means we add D here. Then we can join that like that. So that on this side we are going to see that we have here C plus D, which is this straight length from here up to here. But this one is C, and this one too is C. I mean D. So that's basically what we are going to use. Now we realize that we need to bring this A plus B and C plus D multiplying together. What does it mean? That's basically length times the width. We will be considering the whole area, the area of the whole of that triangle. Let me give it A, B, C, D, and let me shade one. The whole area of that will be given by this. Let me name this one RS here. The whole area of that will be the area of this plus the area of that. So we can say that area of rectangle A, B, C, D will be given by area of rectangle A, S, R, D, this one, this section, plus the area of this area of rectangle S, B, C, R, this other rectangle. And now that we see that our area of rectangle ABCD is given by length of that and width of that, which is A plus B times C plus D. So we have A plus B multiplying C plus D. So that here area of our rectangle ASRD is this one, which we have the length is A, and the width there is C plus D. This side is the same as this side. So that we do have here area of rectangle ASRD will be the length A into the width, which is C plus D, plus the area of now SBCR, this, which will be B into also the width, which is C plus D. Now we can expand that, and we see that we have A from what we discovered before, that is here. A term multiplying two terms, an expression of two terms is given by that. It multiplies each term inside the bracket, and that's what the same thing we're going to do for this and this. So we have here AC plus AD D, this multiplying each term from what we discovered before, and here B also multiplying each term, B, C, plus multiplying that we have B, D. Therefore we have our A plus B multiplying C plus D to give that, and that's how we come to that. And now the next thing we're going to do, we're going to maybe, okay, we can realize that I first make a conclusion here before we proceed. If you realize that here each, like the second expression which has C plus D is being multiplied by each term inside the binomial expression A plus D. If you can see here, the second one is multiplied by each term in the first expression. That's how we can come to that. You can make that C plus D is multiplied by each term in A plus B. Okay, you can look at maybe one example. Let's say we have example. Let's say we have x minus 10 into 2x plus 1. We consider this, we have that, we apply what we did before that. Each term in the first expression must multiply the second expression, that's x is multiplying now this. The first term is x, which is going to be multiplying 2x plus 1. The second term is negative 10, which is multiplying 2x plus 1 also. Then we also apply what we discovered first from single term multipliers, which is x multiplying that becoming 2x squared, then times plus x times 1 giving x, then 10 times 2, negative 10 times 2x will be negative 20x, then negative 10 multiplying 1 will be negative 10. We can just collect, make them, we have 2x squared and minus 19x. We have x minus 20x, which is the result is a negative value, which is negative 19, then minus 10. That's basically what we have. So we can go to, we have to go to now the three identities of a quadratic, or the three quadratic identities. But before, let me first make some conclusion here. Let us say, let's consider around 3 examples. Let us say that, let me say I have x plus 1 into x plus 2. We try to expand this. We're going to have x multiplying each term here. We're going to have x into x plus 2 plus 1 into x plus 2. We expand that, we're going to have x squared plus 2x for that, then plus x plus 2 for this, so that here we can say x squared. Let us factorize out x. We have 2 plus 1, then plus here we have factorized out x, then here we have plus 2. And we realize that 2 is multiplying 1. Let us group that one also like that. Now we see that here we have a sum and here we have a product. That means it can lead to actually a pattern that we can have. But now we can also first of all say that in case now here the coefficients of these first terms, this x, are not a unity, actually I can say that they are different, they're not the same. Let me say here is 1. You can check on another one. When the first term coefficients of first terms not a unity. We look at an example. Let's say 2x, seeing this first term the coefficient is 2 plus 5, applying the second term with 3x, which the coefficient of x here is 3, applying the second expression with 3 as 3x plus 2. So if you see here, we have coefficients of first terms here and here. They are different. And so if you see that, we will say that we have here 2x into 3x plus 2 plus 5 into 3x plus 2, according to what we derived before. We're going to have here each one multiplying. We're going to have here 2 times 3, 6, which has x, so we have here 6x times x giving x squared, plus here 2x times 2 giving 4x, then plus, we're going this side now, we have 5 times 3x, which is 15x, then plus 5 times 2, which is 10. Then here we have here 6x squared, plus we have 4 plus 15x plus 10. Here that means here we're going to have 19, then 10 there. But 10 is given by multiplying. Let me put it in form of multiplication because it's something I want to bring. Type that. Here this is just the same as 6x squared plus 19x then plus 10. That's that one coming. So I want us to realize one thing, that if we have this like this, I want us to see this once again. 2x plus 5 into 3x plus 2. We're going to get a pattern of getting this and getting how we get actually the coefficient of x, this one in the middle here, 19x, how we get that coefficient, because the highest power here we realize was going to be x to power 2. X would have the highest power, which is 2, and we go to the next one below that, which is x to power 1, which is 19. We said that 19 will come about by multiplying this with that, with this 2, then adding it to this times that. So you realize that we have 2 times 2 plus 5 times 3, which is 4 plus 15, giving us 19, which gives us that middle term. So we I'm bringing this because I want us to get like a quick way of getting this expansion, even if it has coefficient of, even if the first terms have coefficients of 1 or any of 1, or they have same coefficients, you still use the same method to get the middle term. And this, to get this one here, is just this one, the coefficient of the x squared, is just multiplying the first ones here. This 2x, the first term, just multiply the two first terms, which is that you get by multiplying the coefficients of the first term. That's 2 times 3, which will give you 6x squared. And to get this coefficient of x, then we have here we have coefficient of x squared is going to be this 2 times that 3, 2 times 3, which is equal to 6, which is multiplying coefficients of first terms. Then we get this 10 by multiplying second terms only. We got term 10, 6x squared plus 19x plus 10 by multiplying second terms. So we got this 10 by multiplying the second terms. Getting coefficient of the x squared, we multiply the first term. Getting the coefficient of x, we multiplied the coefficient of the first term with the second term. The coefficients of first terms and multiplying with the second, the value of the second term to give, and we add them to give us that. So we're going to say, I just want to show you a quick method of getting of how to get get the result of multiplying two binomial terms, two binomial expressions. So let's consider now another number. Let me say 3x minus 2 into 4x minus 5. Quick method. So that means here we have, remember I told you to get the, we have x squared, the highest term will be x, and we have x, and we have the term without x. Term with x squared, term of x, and term of a number without x. So that here, to get the coefficient of x, we are going to multiply this first term, which is 4 times the coefficient of the first term. To get 3 times 4 will give us 12. To get the coefficient of x, we multiply the coefficient of the first terms with the second term, then we add them together. Coefficient of first term multiplied with the second term, that one. So that to get that coefficient of x, we're going to multiply 3 by -5. 3 times -5, which is -15. Then we add to 3, we add to this -2 times 4 to give us -8. Coefficient of first term multiplied with second term, you add them. Even this coefficient of first term multiplied with the second term. So that's why we are adding them to get that -15 plus -8. We're going to have 15 times 8, we have here 4. Then we have the 12, 120, but negative, since we are adding. We're just adding, that's -23, sorry, minus 23. Then to get our whole number without the x, the term without x, we're going to multiply simply the second terms. That's -2 times 5. That means we are going to have negative times negative. Remember I told you in the same sign multiplying, the result is positive, so we're going to have 10. That's a quick method of getting that. So that you have 3x minus 2, I show you 4x minus 5. You have 3x into 4x minus 5 minus 2 into 4x minus 5. Using that, we have here 12x squared minus 15x minus 8x, multiplying that, plus 10. Multiplied this to get that, multiplied that to get this, then multiplied this to get that, multiplied this to get that. So that here we have 12x squared, -15 minus 8, that means we're going to have minus 23x plus 10. See, we have the same value. This was a quick method. This is now going through the normal way thing that we have been learning. And that's enough for now. We can check now another thing. We look at the 3. This is C now. Is it C? Yeah, I think C. The 3 quadratic identities. They are here. A plus B squared is given by a squared plus 2ab plus b squared. If you use what we have been using, just repeat this. I mean like this, a plus b into a plus b, what we have learned before to get that. But we're going to show you how it comes about using the same thing of area of rectangle, of squares or rectangles of figures, at a rectangle of area of rectangles or area of squares. So we have that. Another one is this, a minus b squared giving us a squared minus 2ab plus b squared. And the third one is a plus b applying a minus b giving us a squared minus b squared. You're going to see how this comes about, but if you follow the normal way that we have been learned, that we covered before, you can still read this. So the first one you're going to check for is a squared, a plus b squared, which is given by a plus b into a plus b, which gives us a squared plus 2ab plus b squared. Now we're going to consider, we have to first see this and that we are going to consider from here to here. This is what we are going to use. That means we need to create a plus b. Let's create a here and b here. Is that what we are supposed to have? Okay. That could also work. Then let me just say this. Let's put a here because I want to add b. It's going to be a lot easier. Then b here. We're going to have here a plus b here. Now, since we want to say that times that comes only if a square. So you know, a square is side times side, which sides have the same values. So that means even this side we need to create another. Yeah, this also, now we have seen that has come. That means we also need another a plus b there. So we create here a and create a second one. Say b. Join. Sorry, I have limited space because I didn't plan before. So here I have a plus b also. That means even this side would be a, just like before we had suggested. That would also mean here is b, here also b. So that means actually here we have a square of area. I mean this, I'm meaning area inside here. Area inside here is ab, that side and side. Then the area, that means this is a rectangle different, this is a square, this also a square because it has same size. See, so b is coming here. This length is the same as that length. Even here a is here, that length, also a there, that length. So now how do we need to create this a plus b multiplying itself. That means we're going to actually have area of the whole square. It's not a square, same side, you see that? So area of the whole square, let me say a b c d, the square a b c d is going to be given by area. Now I need to see, let me see what I need to put here. I have here this a. I think we just need to add these two areas, that and that, to get the area of the whole of this square. Let me just shade this. Okay, let me put here s r, area of, now we have a plus b here, also a plus b, then a area of the rectangle. That's not a rectangle because here we have a plus b. Seeing that we have a rectangle, but this, it has side a here, but here is a plus b. That means it's a rectangle. ASRD plus area of the another rectangle is here, a plus b, and here is a b, sb, that, and here is a b here. Area of the rectangle SBCR. So now that means we are going to have here area of this whole square is going to be a plus b into a plus b, which is going to give us area of the rectangle. This is going to be a times a plus b, this side length and this width, a into a plus b, plus this one SBCR is going to be b, which is this, times that, which is a plus b. We have seen how that comes about. So here we have the one giving a plus b. Now we square now what we wanted before. Here it's given by, we will now open that, a times a is a squared, what we learned before we can apply here now, plus a times b plus a times b, which is still ab, plus b times b, which is b squared. So a plus b squared will now give us a squared, a plus b, ab plus ab, which is now 2ab, then plus b squared. That gives us that. Oh, that was lengthy. Now another thing that we're going to look at will be this one, a minus b squared. This one we'll realize it's going to be given by, this is the same as a minus b into a minus b, and it's a squared minus 2ab plus b squared. We need to get that and see how we can come to that. Now we're going to first of all consider how do we create a minus b. Let me say we have here, let's say we have here length a, and that work. Then say I have a length a here, then I first stop there, then another length, let me say here b also, first stop here, that will give me plus b here. Then I say I assume could this be a square. I want this side also to be having okay, just come first join that distance. Now that means some length here should be b, because I want here b to be here, a minus b, the whole of this length to be, let me first split from here, have here, let me say here I have length a minus b, that means that must be b. That is b, that means also here must be b, the same as here. So does it mean here also b? That means this b, that means this one here must be a square. And those things here we have this one, then must be a minus b. I can just say, let me just say, no, I think here a minus b, a minus b, a minus b here can be, let's put here to be length a minus b, this length here, and we just make the whole of this length here to be, this second one to be, all of this to be, this whole length to be a, and we make this length to be b, a minus b. That I wanted to create a square here. This first should that, so that we have a square here and a square here. No, that's a square, this was a square. Now this is a rectangle, since we have here a minus b. So we can see that all the area of this, we can say, can give us this. We have here a minus b, a minus b here. So we can say that area of this shaded part, which is a square, area of, let me try to draw a clearer one, it was hard deriving that, put here to be a, here also a. I need a dynamic square. Then I create another square here. Let's say this is b, this is b, a minus b here. Then here I create here a minus b, this one here. Let me just join there, a minus b. That means here also b. Now area of the shaded square is going to be given by sum of area of the rectangle and the square. Remember, this is a square, this b is also up here, and remember this, this is a square, this is a rectangle, b here, a minus b here, b here, a minus b. So the rectangles, the one sum of the area of the rectangles and the square, this square, just to get the sum of the, I mean to get a area of the, sorry, it's going to be sum of the area of the whole of the square minus sum of this, sorry. Let's say area of the whole square minus, that is this square here. You have here side a, they're the same. Even if you add this and this, you get a here, the same side. So it's area of the whole square minus sum of area of the rectangles and the square. So we the whole of this area subtracting that area. So that here area of the shaded part will be, we have here a minus b times a minus b. They have same sides, a minus b here, equals to area of the whole square is a times a, which is a squared, minus sum of the area of the rectangles. Area of this is going to be b into a minus b, then plus this one also, which is b times a minus b, then plus that of the square of this square, which is b squared, b times b, to get that area. So that we are going to have a minus b squared giving us a squared into the bracket. We open this, you have here ab opening this minus b squared, then plus ab for this, then minus b squared, then plus b squared. See, minus b squared plus b squared, that will go to 0. We have here a minus b squared giving us a squared. We open now that bracket. We first cancel what will cancel out. We have here 2ab, that combining with that, then this one also go away, minus b squared. And here we have a minus b squared giving us a squared. If you open the bracket, this will be a minus 2ab, then that will be changed to a plus b squared. That's how we come up with this. We go to the last identity. Let me put Roman 3, so that we have for this case we're going to consider, we know that the last identity is a plus b into a minus b, giving us a squared minus b squared. We need to bring that, so we are going to get a plus b and a minus b in a figure. So we can say, let me say I say that a, let me first make a side a here, add another b. This simple for this matter. I say b, so that here I have a plus b here. I've already created that. Then that means here I also put here b, Now I need a minus b. How do we create that? That means we need to make the all of this side, let me say the all of this. Let's first make this is that, let me demarcate that. Means we can make the all of this a, then up b, so that if we make the all of this, let me just make here to be a minus b. Let me just create the all of this side to be a. So I want the all of this to be a, so that up here is b, and I create here a minus b. Sure, is that what help us? That means here will also be a. If there is a, then let us first shade this. We need, how do we bring a minus a plus b times a minus b? That means we are going to have this times that. We can see this figure rectangle here gives us that. Let me shade it. I think a plus b times a, so that we have area of this. That means we need to get the area of this, but area of this will be the area of the whole of that minus the area of that one up. I think that. And so area of the shaded, it's a rectangle will give us, be given by area of the whole is it a rectangle or a square? Yeah, area of the whole, here you have side a, here you have a plus b, area of the whole rectangle minus area of the unshaded rectangle. So area of the shaded rectangle is going to be length times width, which is a plus b into a minus b, that this length and that length, so that we have here area of the rectangle, or of the unshaded, of the whole. This is whole, which is the whole of that is a times that. A into the side is a plus b. This is length, width is a, length is a plus b, which is that and that. Then minus area of the unshaded, which is this length is b, which is the width. Then this one is also a plus b, b into a plus b. Then we now have a plus b giving us a minus and times a minus b, giving us a times a squared plus a times b, which is ab, minus a times b, giving us a b, then minus b times b, positive b, which is minus b squared. This one will cancel out and remain a plus b. That will give us a squared. This one will cancel out. ab minus ab will be 0 there, so we remain only minus b squared. That's how we come to that. And so that we can see an example of the three identity for that can help that can cover the three identities we have covered already. Let me bring another sheet to help us now. An example we can think of, let me say expand. It's an example. X plus y squared. To go to here, x plus y squared. This will be in the form x plus y. I'm applying x plus y, so that we have x plus y squared will now be, we saw from there that it was this was given by x plus 2xy. We're using now the identity that we used before, or we can expand the normal way, if you can, which is the same as this plus y plus y into x plus y. If we expand this, we're going to come up to this. See, this would be x squared plus xy, here xy also, then plus y squared. That's how you'd come to that. It's the same. Then another example, we can look at one of x minus y squared. You'd have x minus y into x minus y. Using the remember our identity here was minus 2xy, then plus, because of negative, y squared, which if you use the normal way, we would have here x into x minus y minus y into x minus y. That is this one, multiplying each term. This we already looked at that earlier on, so that we would have here x squared minus xy, here also minus xy, then negative times negative will be plus y squared. So you'd see you would have x squared minus 2xy plus y squared, which would bring us back to this. Okay, the third one we can look at. So if you have x plus y, applying x minus y, we looked earlier from our derivation that this is given by x squared minus y squared, implying that here if you use the normal way, x plus y to be x into x plus y, then plus y into x minus y. Each term in the first expression, I'm applying the second expression, so that here we'd have x squared plus xy, here also plus xy, then that minus y squared. This is a minus here, because here each term I'm multiplying this, this also multiplying that. That's what we have. So here would remain with a minus, so that our x squared, this would cancel out, negative positive xy minus xy would give us 0 minus y squared. That would bring us back to this. I want us to note this, considering x and y, they are squares. X squared, y squared respectively. And now that means here I want us to observe that. So this is a difference of the squares of x and y, which is this given us difference. Difference meaning minus of two squares. So the formula a plus b into a minus b given by a squared minus b squared is a difference of two squares, which will be a method when we come to solving or expanding algebraic expressions. So the major identities we looked at today. So now we have a plus b squared given by a squared plus 2ab plus b squared. A minus b squared equals to a squared minus 2ab plus b squared. Then a plus b into a minus b was given by a squared minus b squared. This is important and it's worth memorizing. It's going to help us a lot in the future as we continue with pure mathematics. And that's, I can say that's all for today. And thank you for checking out on our videos. Please like, subscribe, and share. Also comment to tell us about what can be improved, and maybe sending in more questions in case you have any query.